Welcome our speaker, Mohammed Akkad. As you can see, he will be talking about building simple yet effective API for the city of Cape Town.
Okay.
Begin when you're ready.
Thank you, Neil. Okay, good day, everyone. Thank you for attending. So, yep, I'm Mohammed Tawfiq Akkad, and this talk was done by me and my colleague who's back in Cape Town, Gordon Ings. And it's about building simple yet effective APIs for the city of Cape Town, Python-powered approach. Okay, so I work at the city of Cape Town, and at the city, our motto is making progress possible together. Right, my full name's Mohammed Tawfiq. I'm a PPO data engineer at the city, and that's my email address, I guess. If you'd like to find out more, I guess you could just email me. So something about data science at municipality, right? Our team is quite a small team. We have about 13 individuals. We have a manager, a product owner, a product administrator, and then we have 2 data analysts, 4 data engineers, 4 data scientists, and our main aim is to enable other branches or units within the city to work better with data. Right, and then there are occasions when you have to do some DevOps and sysadmin work, and then that's kind of loaded on the analysts or the engineers and scientists, right? So we kind of have to do that in a smart way. And then our overall operations, I would say it's about plus minus 90% on-prem and 10% cloud. Right, and then I think the one thing is also that's kind of important. So we kind of a flat team structure, right? And then we do work with data and data science, but you'll see more of that maybe in the lightning talks. Okay, so why do you want to provide effective interfaces to residents? Right, so municipalities provide a range of services to residents such as kind of water, roads, and electricity. And then these services are accessible to residents through effective interfaces such as dams, plumbing, taps, highways, stop signs, and substations, right? But what about, actually, how do you access information about these services? Then information about these services you can access like an in-person visit, a phone call, an email, your municipal website, or social media. Right, but at a developer conference or position to developers, that they prefer a programmable interface, right? But to program to residents who are non-programmers, that question like, why would we need a programmable interface, right? Then you'd ask that resident, why do you need interfaces, I guess, right? So interfaces into municipal services, for example, such as water, they enable just residents to perform the day-to-day functions, right? But on top of that, they also empower residents, right? So you can run your own business, car wash business, some kind of private swimming lessons or something, and some bottled water business and so on. So now let's go back and to the why programmable interfaces. So program interfaces into municipal data allow residents to access relevant information programmatically, which is key, right, in today's age. But they also empower themselves. You're giving residents the ability to empower themselves with access to data. Okay, so now we have the idea and we understand why we actually need this, but let's talk about 2 cases of kind of information that we work with, right, and the data we work with in the space. So we have something called service alerts, and we have load shedding information. Right, so with service alerts, we have 2 kinds of service alerts. Now we have something called a planned service alert. So an example of that is when you need a substation maintenance. So the electricity department needs to, electricity needs to be turned off in a particular area for a period of time. And then what you have in the city, you have something called the TOC team. They kind of measure the severity and then they measure the impact on the severity. And then to them, it's basically yes or no. Do we need to inform the residents it's going to impact? If it's a no, they just resolve it and they kind of record it. If it's a yes, they kind of input it into a SharePoint form and it's stored in an internal data set within the city, right? Managed by some other unit, right? But then you have something called your unplanned service alerts, right? And your unplanned service alerts is when there's a burst water pipe, right? So a resident calls the city to inform them about their burst water pipe, and it goes back to the previous slide where there's either email, a phone call, or something on social media. And what happens then is that they interface with a CRM agent or customer relation management agent, and then that agent queries the data set, right? And if it's in there, they kind of link the calls to that particular data set. And it also goes through the same to the TOC team and the measure severity. And so if it's not in the data set, it goes through unplanned, right? So that's the one where the kind of the data flow. Then the next thing is load shedding, right? So the city's kind of lucky to have the Steenbras Dam, and the Steenbras Dam protects the city from certain levels of load shedding, right? By producing its own electricity through it's a hydroelectric dam, and I guess you could chat after this about that if you'd like to. But then we also have information from Eskom, right? So what happens is you collect the capacity and the stage information from Eskom and Steenbras, and then what the city does is they plan for 2 weeks in accordance with these Eskom stage load shedding and the Steenbras dam. And then what happens, city communicates to the public, right? So this is usually via your social media, your emails, or those things, right? The other one is when you have unplanned. So it's late night, or I don't know, some middle of the day, and then Eskom, some sudden changes happened at Eskom, something happened, yeah, some issue happened at Eskom. And then what happens is they need to create a new plan and they need to communicate. So it's again this unplanned and planned kind of data we're working with, or information we're working with in this case. So as you can see over here, you have your stakeholders that have their own systems. So in this case, they have their own systems that they work with and processes, and the data sits somewhere over there. Right? Similarly, the data sits somewhere over here. Right? So for us, the key thing for a data science team, it's about characterizing the problem. Right? So our key thing is we want to share data equally and effectively with the 4.6 million residents within the city. That's the key. That's the key problem. Right? We want to leave the process that's internally within those particular teams, and it's all about them working effectively with the data as a data science team, right? So for developers, it kind of looks something like this, right? So how do we share this kind of this piece of data with 4.6 million residents, right? So that's the key question you want, and I plan to answer that now, right? So, or you have something like this. This is what a service alert looks like. You have the service area, you have the title, you have the description, you have the area, you have the location, and then some timestamp information, and then you also have whether it's planned or unplanned, right? But this is the two types of data we're talking about in this case. So it's the service alert and the load shedding data, right? So I'm going back to this. After characterizing, we want to frame the problem. So it's actually about sharing data. That's the key thing. It's not an applications problem in this case. It's a data problem the way we're viewing it. And then taking from the Zen of Python, we want to make it simple is better than complex. We want to keep it simple as possible, like as simple as possible. And then talking about program interfaces or APIs. For us, it's about the developer experience, not the user experience. Right. So we want to make the developer experience a really good experience. Right. So going back to, so I'm a data engineer. I look at things as data pipelines. So to me, the thing that scales and the thing that scales the best is if you take this file, you make it a JSON file, you host it on S, and then you put it on CloudFront, and that's PubSub Uncle. That's basically it, right? So that it scales, and you have okay, sure, but like, how do you do the updates and how do you get alerts on these things? But then the next step, what we decided to do is we tried to hook it up to Amazon SNS, right? So we were looking for something that was lightweight, something that scales really well, and it also won't affect our cloud bill in a crazy way, right? To these 4.6 million residents, right? Then, as you're aware, SNS, Amazon, or if you're not aware, but Amazon SNS has different interfaces to broadcast like the updates. And one of them is they have like an email, and it's not SQS, it's just standard SNS email, right? And it's free up to a certain amount. It's quite low costing thing. Then we have SMS, but that's only for like certain priority users. We actually, I think, I have 1 to 3 users, and those are only internal users who requested that, right? But then you also have something which is the SNS topic, And you also have these webhooks that Amazon publishes, right? So when the change happens to the bucket, we can publish that. Okay, cool. So we solved the alerting problem, right? But then how do you update this file? So internally, what we do is we have a bunch of Airflow tags. These are basically Python scripts, right? If you're not aware of Airflow, it's basically just a different version of cron, right? And we retrieve the data from SharePoint in the case of the service alerts, and we write it to this S3 bucket, right? But in the case of load shedding, we just have a simple web tool that allows him to submit these stage changes, right? And then update the JSON file, and it gets reflected. So, okay, so you're talking about a lot of AWS, where's all the Python? So, no, it's like full of Python. The internal data pipelines on the control plane, the Airflow tags, right? Python. On the data plane, we have Python over there. For the data extraction, we have Python over there extracting the data from your SharePoint or wherever else is sitting. And then externally, we have some AWS Lambda functions. And the key thing for us about the Lambda functions was we didn't want to add any other dependencies to it. So I want to keep it as lightweight as we can using the stock standard Lambda runtime API. So we didn't want to load any other Docker things, so we could keep that like a very low kind of footprint and low. Yeah, that's why we kind of like Python, right? That is included. So how do we integrate with these endpoints? So we have some JSON endpoints, and this is where I'll be on that. So these are some of the JSON endpoints that we have, right? So how does it actually look? So let's click on here. So we have the current status. It looks something like that. Okay, this is my browser, but that's the raw data, right? So yeah. And then we have the schedule for the city of Cape Town, which is this long schedule. It's about a 200 kilobyte file, but you can kind of reduce it, right? But it's for historical purposes. We're a data science team. We want you to have access to all the data, right? And this is updated when we have these internal changes, okay? And it's free to use, right? Then we have a bunch of, okay, so that's the JSON, the files. And I mean, you guys are developers, you know how to use that, right? So I won't speak much more about that. So we also integrate with the endpoints. We have these Mastodon bots, right? And these bots kind of tweet the service alert. Toot the service alerts. So let's click on that, and you'll see over here. These are the service alerts, and then there's some funky stuff that's happening over here using our internal CPT, GPT, and we're pushing it from Airflow to Mastodon. But we're taking that JSON file and we produce some output there, and then we also explain to you that it's automatically generated, and so you can access it. So it's about accessibility, right? So we also have kind of the tweet text if you want to tweet text over there, and then it's the other service alert information. So let's go back here. Yeah. So we also experimented with building bots. So we worked with the guys down here in Durban, the OCL labs, Open City Labs, and there's kind of a bot that they built. They use the SNS topic plus some other AWS services, right? And this WhatsApp bot kind of updates you when there stage changes on load shedding, and it also updates you when there are schedule changes, right? Schedule changes and when the stage change. Then there's also a Signal bot that's on our GitHub page that was done by colleague Gordon, which is a Flask app, and it uses the webhooks, right? The AWS SNS webhooks. And then there's also a Telegram bot that I kind of experimented with, which uses the SNS email and Cloudflare workers. So we want to show the kind of the flexibility of the solution. You can go from using something like WhatsApp that requires like a paid API to Signal that you can host your own API, then to Telegram, where it's like everything could use basically free services, and we also using just the SNS email in that case, right? So the other one is what we also were able to do is we spoke to our team within the communications team, and you all know Jason. Jason, you can work with us. So we integrated with the city's website. So if you look at the city's website, so this is the website that has the load shedding information, and you can see over here that it pulls the JSON file, right? The data from the JSON file, the extended status, and some other information. But so this is dynamic, right? Previously, this was done every day at 5 a.m. The communications team had to schedule an individual to actually change it, or when the changes happen. So if ESCOM changed the schedule at like 1 a.m., someone in the communications team had to edit the website. Yeah, so we helped them in that, and they were quite grateful in that aspect, and it was a good collaboration. But it goes back to what our team's aim is, to enable teams to work better with data. Right. Okay, and then this might look familiar to you. So yeah, they also we have well, Gordon has a good relationship with the guys down at ESCOM Sabush, and they also use those JSON endpoints to update their application, right? So it's used as the source, and they also use the service alerts. I'm not aware, right? So there's great relationships we're kind of building as the city's building with these app developers, and then also the city has its own app, and it's also using its own app, right? So that's the great thing about creating these platforms and interfaces into data that allow not only the residents but everyone else to actually interface with it, so internally and externally. Okay, so just to conclude, and I think I went a bit way too fast maybe, but just some time for questions. It's a lightweight and easy source of truth equals greater access, right? And then it goes back to our key kind of motto at the city is making progress possible together, right? And then public engagement through data APIs. That's one of the key goals of our team, is to engage with the public through data APIs. So this is third-party applications, emailers, bots, websites, your own root Goldberg machine that's sitting somewhere. But that's basically how we work and what we'd like to do. And then, yeah, I think it's time for questions. That's a link to the gist with pretty much the SNS topics, the emailers, some of the apps that were built and things. And then that's my email address. And then I think the old motto of the city was, "The city works for you," if you remember. But I just wanted to end up and say you could also work for the city. Yeah. So contact me. Cool.
Right.
Thanks.
Thank you very much. Do we have any questions? Give a couple of minutes to see if there's also any online question.
Cool. Thanks. Good one. I think it's very simple from what it seems, but it works well, right? Quick question though: why are you guys using SharePoint to load the data from the thing? Is there a specific reason? Do people don't want to work with other stuff?
Yeah, so that's I think if you work in these big kind of corporate, there's so we're not IT. We don't work within IT, so we can't mandate the usage of particular applications or tools. We can mandate how you work with data. So it's best for us to work with data the way teams work with it. And so we don't want to go in there, build you a new app, understand your process and those things. That's not. So for us, yeah, just in response to this question, which is this one over here. Yeah. So whatever you the way you work with data, we store it, your source, we take it out from there and we build coherent data sets. So outside of this, so this is like a very novel kind of data science. It's a very novel data science kind of task that we did, I guess. But for us, the key thing was let them work better with the data. So to answer your question, no, we're not IT. We don't. We're not within the IT department. We're outside. We're in a department called well, we're in a directorate called Future Planning and Resilience. So that's so yeah, our mandate is more on enabling teams to work better with the data.
We have an online question. Why a 200 gigabyte file? Is there no way to optimize?
No, 200 gigabyte, no, kilobyte, sorry, pronunciation. It's no, it's 200. Okay, why? So 200, yeah, probably if it grows bigger, we can do things. We can change it and just make it as simple. But we have the status file, right? So the status file will show you what's currently just there, but the extended status file has all the historical data. Yeah, no, sorry, it's a pronunciation on my side.
All right. Any further questions? Okay, let us thank the speaker.